Hello everyone, welcome to this lecture. In this section, we would like to talk about unions in C++. So unions in C++ is used when we want to store different types of data in the same memory location. So it allows only one of its members to hold a value at any given time. Thus, it helps to save a lot of memory, and it is particularly helpful when we would like to optimize our memory usage. One of the benefits of union is that its size equals to the size of its largest member. So it helps to save a lot of memory. In order for you to better understand it, I'm going to compare unions and structures that we learned in the previous section, so you would have a better idea how union differs from structure. So in a structure, each member has its own memory location, while in unions, all members share the same memory location. And in the structure, the size of the structure is the sum of all member sizes. However, in union, size of union is equal to the largest member size. In a structure, all members can be accessed simultaneously. However, in unions, only one member can hold a value at a time. In structure, we use it because when we want to store independent values, but in union is used for memory efficient data management. So whenever data management for memory efficiency is critical, we're going to use unions. And finally, in structures, multiple numbers can be initialized, while in unions, only one member can be initialized. So now I'm going to give you an example of how to declare and initialize a union, and in the next video, I'm going to provide you with a code comparison between a structure and a union, so it will give you a better idea. But before that, we need to understand how to declare and initialize a union first. So here we would like to write a program that demonstrates basic union usage, and we are going to declare and use a union. To declare a union, we are having the reserved keyword union, and then we type down the name that we want for our union. In our case here, I'm typing data as the name. Then the data union is having two variables. One of them is integer, one of them is float, and their names are respectively myInt and myFloat. Then in the int main function, I am having a new variable declared here. It is of type data, and the data is the name of our union. So this d variable is of data type, which is a union. And in order to store an integer in our union, I'm going to type down the variable name dot the name of the variable in the union. So I'm going to type down this variable name, which is d dot the element of the union, which is myInt dot myInt, and now I'm storing an integer in my union. And now I'm going to print out the value using d dot myInt. And then in order to initialize a number for the float variable here, I'm having again the variable d here dot myFloat, and it equals 3.14. So we are storing a float. But one thing to mention is that it is overwriting the integer variable here that we declared already. Because if you remember, we mentioned that only one member can hold a value at a time in unions, and only one member can be initialized at a time. So it is when we are having this being written, It means that it is overwriting the integer. So let me run the code. So when I run the code, I see that I'm having the integer equal 42 and the float equal 3.14. We see that we could access the variables that we initialized. However, if I'm going to print out this integer here again, we will see that it does not show a good value. Okay, this is a garbage value that we see for this integer as expected. Why? I'm going to explain now. So first, we are declaring an integer. Okay, we're storing the integer and we are printing out the integer. It's okay now. Then we are storing a float number that is 3.14. The point here is that this float is being overwriting the integer. So now that I'm printing out the float here, the integer is now taking a garbage value. Why? Because float is over writing the integer, because they are sharing the same memory location, and because we only have this, they are sharing the memory location and they are having the same memory location. Only one variable can be stored in that location at a time. This is why integer is now taking a garbage value. Okay, so this is the main difference between a union and a structure. When we are initializing a new variable using a union, we are overwriting the previously initialized variables, as we see here in this example. So in this example, I am initializing the integer. I am showing out the integer in the terminal, which is here. Then I am initializing a float, but this float, because it is using the same memory location, it is overwriting the integer. So that integer that we initialized before now is a garbage value because we overwrite that. Then we are printing out the float, but because we would like to prove that we are overwriting, I print out the integer value one more time. So we see that the integer is taking a garbage value. So this is the main difference between a union and a structure, because they are using the same memory location. In union, they are very memory efficient and they are as large as their largest variables. So they are having one variable at a time being initialized and being used. So this is why they are very important to be used when we are having critical problems in memory management. In the next lecture, I'm going to give you a code example, a coding exercise to compare again a union and a structure, and then we are going to dive into more coding exercises with respect to unions. Thank you for watching. Hello everyone, welcome back. In this video, we would like to write a program that calculates the size of a union. So here we are having a declaration of a union data, and in the int main function, we are simply printing out the size of this union. In order to have the size of this union, we are printing out size of union in the terminal, then using the keyword size of, and in the parentheses, we are having the name of our union and then the bytes here. So when I run the code, we are going to see the size of union, and then the number 8 is being printed, which is of bytes type. So it is going to have 8 bytes of memory usage, this union. Thank you for watching. Hello everyone, welcome to this lecture. In today's video, we would like to write a program that demonstrates anonymous union usage in a structure. To do that, we are having a declaration of a structure called test. And this structure is having one character called C and also one union is inside this structure, and this union has no name, so it is anonymous union. And this union, we are having one integer and one float, and the name is I and F respectively. In order to access and initialize these variables, we are going to have a new variable called t of the test data type, which is the name of the structure. And then we are directly accessing the variables of the union with no name. So we are having this t.I to initialize the integer, then t.c to initialize the character, which is of the structure element, and it's outside of this union as you see. And then t.f equals 12. So we learned now how to initialize some variables for a union with no name or an anonymous union. And we learned also how to declare an anonymous union. So we simply use the keyword and then we are having the brackets. And in order now to print out these assigned variables, we are having the cout, so the integer value to be t.i, then the character to be t.c, and the float to be t.f. However, we expect to have a garbage value for this line for the integer, and the reason is this I and F, which are these I and F, are inside the union. And when we are declaring and initializing the I here, and then we are initializing the F here, this F is going to overwrite this integer. Therefore, because they are using the same memory location, this integer is now a garbage and overwritten. Therefore, we expect to see a garbage value for this integer. So let me run the code. Okay. So as we see here, this integer is taking a garbage value. Then we are having the character A to be this line t.c. And then we are having the float equals 12, which is t.f. But if I remove these two lines, we expect now to see a good value for the integer, so it will be printing 10 in this location when I comment this float, because it's not going to overwrite the integer anymore. So when I run, exactly. So when I run, I see that the integer takes the value 10 and the character takes the character A variable. Here it is shown. So in this lecture, we learned how to declare and initialize a union with anonymous members and an anonymous union with no name. So we declare it here inside a structure, and then we access directly without union name. And we also tested the overwritten concept in unions again as well. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that compares a union and a structure. We are going to initialize one structure here using the keyword struct, and the name of the structure is a struct example, and we are having the int and float variables called I and F in the structure struct example. And then we are having a union that is called union example. We are having the same variables, and they are integer and float, and they are called I and F respectively. Then in the int main function, after finishing the declaration of the structure and the union, in the int main function, I'm having the initialization of a structure and a union. So in order to initialize a structure, we learned that we need to declare a new variable, and the new variable here is called s, and it is of the struct example data type. So it is of this structure type, okay? And using this line, I am initializing basically the integer to be 42 and the float to be 3.14. So this is how we learned it in the previous section. This is how we're going to initialize a structure. Then I am initializing a union. So in order to do that, I'm having the union example, the name of the union, and then the name of my variable. And in order to set some value for the integer and the float, I'm using this variable name, which is u, then point the elements of this. So I'm having the u point I, the name of this variable in the union, to assign the integer I. So I'm having u point I equals 42, which means that this integer, I'm using the first variable integer here and setting it to be 42. Then I am initializing the float here. So the float is 3.14. However, the important thing here to know is that this float overwrites the UI, this integer. Why? Because we mentioned that it is they are sharing the same memory location. So they are sharing memory location and they are using the same memory location, and it can store only one variable at a time, only one variable at a time. So it is important to note that. Now this float is overwriting this integer, okay? Then we are printing out the structure integer and a structure float using this line, using structure I equals s dot I and f equals s dot f. Then I am printing out the u dot I, which is the union, so u dot I, the union integer and the union float. I expect to see a garbage value for my integer here. Why? Because the integer was declared, and after that a float overwrote that integer. Okay, so because it is overwritten, we expect to see a garbage value for the integer because the final declaration was for a float. So let me run the code. Okay, so when I run the code, I see the structure I equals 42, which is this line, this part, and the float is 3.14, which is correct. However, for the union, we are seeing a garbage value for the integer and the float number is correct. So it means that when we are comparing a structure with the union, we see that it overwrites the previously declared variable. So this is the main difference between a union and a structure. And we learned how to initialize a structure, and we learned how to initialize a union. So we are having this variable u of the union example type. Then u.I gives us the permission to access this I, and u.f gives us the permission to access this f. And if so, it depends on the name of this. So if I have, for example, another integer called myInt, in order to access this one, I can have u.myInt, okay, equals 10, for example. So it depends exactly on the name here. So u dot the name of the variable here, whatever it is, you can initialize the value for that, and then we can basically print out the variables using s dot the name of the element, s dot the name of the element, which is f, and u dot I the name of the element, and u dot f the name of the element. Thank you for watching. In the next videos, I'm going to give you some coding exercises with respect to unions. Hello everyone, welcome back. In this lecture, we would like to write a program that passes a union to a function. To do that, we are having one union initialized here called data. It is having two variables of integer and float type. Then in the main function, we are having a d variable declared of the data union data type. We are initializing its integer value using d.a equals 42. Then we are calling the function print union. So we are passing the union to the function. So we are passing this variable d that is declared here and a true argument. So for this function, we need true arguments, two arguments. So here is the name of the print union function. So this is the name print union. It's a void type, so it's not going to return anything for us. And then we are having the two arguments here. So we are having in the second argument, we are having a Boolean variable that is called isInt. So the second argument must be a Boolean variable, either true or false. And in the first argument, we are going to have this d variable, which is of the structure, which is of the union, data type, and it is a call by reference because we are having this and here, and the type is the data, which is the union name. Then in this function, we are simply having one if else condition. So we are saying if isInt, so isInt is the condition in the parentheses, which is this Boolean here, means that if this is true, is int that is passed as the argument, the true is passed, it means that you need to enter this part of the code and print out integer d.i. Otherwise, if it's not true, which means that if it's false, then cout float d.f. So here we are, after calling out this function, this line of the code is executed. Then we are initializing the d.f, which is the second element of the union here. And then we are calling the function again. We are passing the d variable, then the false argument as the second argument, the Boolean one, because now it's a float, and for the float case, we are going to pass the false, and for the integer case, we were going to pass true, because if it's true, it is going to print integer, otherwise it is going to print out float. So let me run the code first, and then we're going to discuss more in details. So here you see that integer 42 is print out here when we first call the function, and when we call the function for the second time, it says float equals 3.14. In order to review this code one more time, we would like to write a program that passes a union to a function and prints out the value that is passed to the function. To do that, we are having a union being initialized here, declared here. Then we are having the main function. We are having a new variable called d. It's of data type, which is the name of the union here. We are assigning the first element integer to be 42. Then we are calling the print union function, and we are passing two arguments, d, the name of the variable, and true, which is a Boolean argument. So here, when we call the function, we come here. We have the name of the function print union. It's a void data type, so it is not going to return anything. And it is having two arguments, and they are separated by a comma. The first argument is the d of data type, and it's a call by reference because we see an and sign here. Okay, so the variable of the data is passed here using a call by reference, so the function can directly access the variable. Then in the second argument, we have a Boolean variable, and the Boolean variable here is true that is passed. Okay, Then in the main function, in this print union function, we are having one main if-else condition. We are saying that if the second argument, which is int, which is int here, which is passed to be true, if this is true, in the parentheses, if true is passed to this function, we are having the cout integer d.i, so it is printing out the integer equals 42, and it is not going to enter this else part because in the first call for the function we are passing true. So passing true means that this part is correct, so the compiler is going to execute this line of code and it's not going to enter this else part. Then this line is executed. We are initializing d.f to be 3.14. Then we are calling the function one more time, print union, and we are having the d, the same variable, and false this time as the second argument. So here, when we are calling the function, it checks is it true or not? If it's true, it's going to print out this part, but it's not true because we passed the false. So it is not going to pass this condition in this parenthesis. Then this part is skipped, and then we are going to enter this else part. So the else part is the float, which is going to print out this line of code for us. So basically, when we are having the isInt and we are not having any equal sign, it means that if this is true, if this isInt equals true, enter this part, otherwise enter this part. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that uses a union to store either an integer, a float, or a character. Take input from the user and display the value. This is what we're going to do. Here is my union. Using the union keyword, I'm declaring a union called data. And there are three variables inside my union. One integer called I, one float called f, and one character called c. In my main function here, I'm having an object being created from this union. So the object is called data. This is used to access whatever that is stored in this union, okay? Then I'm having an integer called choice. This message is shown to the user, select the type of data to store. After that, we are telling the user enter 1 for integer, enter 2 for float, and enter 3 for character. And whatever the user is going to enter is going to store in choice. And this \n is going to help the compiler to go to the next line before printing the number 2. So we are saying number 1 in the first line, then \n will help the compiler to go to number 2 and to the next line, and then number 2 starts. Then after the t being printed in the terminal, it goes to the next line again, and number 3 character is printed out. So whatever the user is going to enter is going to stored in the choice variable here. Then we are having the switch statement to have the checking for different conditions. Here I'm having the choice in the parentheses of the switch statement in the conditions, let's say. So if the choice equals to 1, so it means that the user entered an integer. We are going to ask the user enter an integer. Okay, so here the user says that I would like to enter an integer. Then because the user entered 1, we know that they want to enter an integer. So this part of the code is being executed because choice equals 1 now. Okay. Then we are showing this message to the user, enter an integer. Whatever that the user is going to enter is going to store in our union here. How? Using an object called data here we created dot the variable of the union that is called I, and use the cin syntax as always to store it. Then we show the stored integer to the user, and we need to break afterward in switch statement. If the user enters float, the same thing happens, but this part is being executed. So we ask a user to enter a float, then the float is stored in the union using the object of the union, that is data, dot f, which is the float variable of the data union. And also, if in case that it is character, we are going to store it using the C variable, which was initialized in the union for a character. Okay. And we have a default value here, default condition here. Let's say if the user is going to enter something that is neither 1, 2, or 3. Let me run the code once. So when I run the code, select the type of the data. This message is being shown in the output. Then it says integer, it goes to next line because of \n, then float, and then it goes to next line because of this \n and character. So I would like to type down 1. When I enter 1, it comes to the switch statement and says, okay, choice equals 1, and in case you entered 1, we are going to execute this part of the code. So enter an integer. This message is shown. So whatever that I enter, it is going to be stored in I variable using data object. So I would say 20. It says stored integer 20. So see out the message in the store integer, and to access that number that we stored for this I variable, we type down the object dot the variable name. So data dot I is going to help us to have the output here. So when I run this code one more time, it says what do you want to enter? I would say this time I would type down 2 because I would like to type down a float number, for example, and then enter a float. I say 3.14. So it says the stored in float is 3.14. So here enter a float. So enter a float message is shown. Then whatever I enter is stored in the f variable of the data union, and this is the object of the data union. It is also called data with small letter d. And then the stored float is being shown in the output here using this line. So I'm using the object data dot f. F is the variable that we use to store floats in the union data. So this is how it's going to work. And if I enter, for example, 5, it says invalid choice because we have only cases 1, 2, and 3. So there is no 5 here. Whatever that is that the user is going to enter apart from 1 to 3, it's going to show the invalid choice message in the output. So this is how we can declare a union and also have different variables in the union and ask a user to enter one, for example, one number or one data type that they would like to store in our union. Then depending on what the user is going to choose, we're going to take that number and store it in our union. Thank you for watching. Hello everyone, welcome back. Here in this video, we would like to create a union to represent different types of sensor data. For example, we would like to have temperature of float type, pressure of integer type, and status of character, and display the data based on the user choice. Here I'm having a union called sensor data. It has 3 variables, one float, integer, and character. Respectively, they are named temperature, pressure, and status. In the int main function, I create an object of this union called data, and I have one integer called choice. So I show this message to the user. Select the type of sensor data to enter, and then for temperature, enter 1, for pressure, enter 2, and for status, enter 3. The user's choice is going to be stored in the variable choice here. Then we are having a switch statement. So if the user is going to enter 1, it means that they want to store some temperature, store a temperature, a float number temperature, okay? So in case 1, we are going to ask the user enter the temperature. We are going to store it using the object of this sensor data union, and then dot the name of the variable that we created for this purpose, which is called temperature, and then we are going to show it to the user. In case they're going to enter 2, we're going to store it in the pressure variable here that is of integer type, and then if they choose number 3, we are going to store it in the status variable from the sensor data union using the object that is called data, and any other number apart from 1 to 3, if they mention, we are going to fall in, this is going to fall into the default case, which shows this message to the user, invalid choice. When I run this code, we see here it says select the type of sensor data to enter. So I would like to say, for example, temperature. Enter temperature. I would say 5.12. It says temperature 5.12 is shown in the output, and we try to have this degree here, but it is not going to be shown very nicely. So I would just remove it and run one more time. So I would say temperature 5.12, so it is going to show temperature 5.12, for example, C for Celsius here. Okay, so let me provide the space here. Okay, so if I run the code one more time, here it is going to mention enter, for example, select the type of the data to enter. So I would say 2 pressure, so enter pressure and integer, I would type down 7. It is going to show me pressure 7 PA. PA is the measurement, is the unit for the pressure in physics. So 7 PA is shown in the output, and how it is shown, because I entered 2 here, we implemented the case 2. So it asks me to enter pressure integer. So enter pressure integer, so I put 7, for example. So it is going to store it in the pressure variable here in the union sensor data, and use this data object that is declared here to store it in the pressure variable. So data, the object dot the name of the variable, which is pressure, it is going to store it using in syntax, and then we are having the message in the output pressure here, pressure colon, and then data dot pressure is going to call this number that is stored in the union, and then we are having the PA, which is the unit of the pressure that we're showing in the output. And also, if I, for example, it asks me to select the type of the sensor, if I enter 10, it says invalid choice, because 10 is neither 1, 2, or 3, so it is going to say invalid choice. Thank you for watching. Hello everyone, welcome back. We would like to write a program for managing employees' data. So we would like to use a union to store an employee's ID or department code based on their roles, and allow the user to input and display relevant data. I'm having a union called employee data. It has 2 variables, ID and department code. They are of integer and character data types respectively. I'm creating an object of this union called EMP, and one integer variable to ask the user to enter their type of employee data that they want to enter and store it in the choice variable. So I show this message, select the type of employee data to enter, and then if you want to enter ID, enter 1. If you want to enter department code, enter number 2. And whatever the user is going to enter, we are going to store it in choice variable. And writing an if condition here would help us to proceed with the program. We say if choice equals 1, we are going to ask the user enter employee ID. It means that they wanted to enter one ID, because we said if you want to enter ID, select 1. So we are asking the user now enter employee ID, and we are going to store it in the ID variable of our union here. So the union name is employee data. Its object is called EMP. Using the emp.id, we're going to store the employee ID in this ID variable in this union here. And if the choice equals 2, it means that they want to enter department code. And if they want to do that, we are showing this message to them saying that enter the department code. Then using this, again, the object of the union dot the department code, this is the name of the variable of this union. We're going to store it, and then we are going to show this to the user that you enter this department code. And if the user is going to choose anything apart from 1 and 2, it is going to fall in this part, else, which mentions that it's an invalid input. So when I run this code, I see that select type of data, employee data to enter. This message is shown. Then these choices are shown here. 1, if you want to enter employee ID, for example, enter 1. If you want to enter the department code, enter 2. So I want to enter an integer. I would type down 1. It says, okay, enter ID. I would say the ID is 10, 20, 10. It says employee ID is 10, 20, 10, and it is stored in this ID integer in our union employee data. So when I run the code one more time and I enter, for example, 12, it says enter 1 to enter employee ID and enter 2 to enter department code. I mentioned 12. So 12 is neither of the cases, neither 1 nor 2. So it is going to fall in this else part where it mentions invalid choice. So this is how we can have a union of employee data, and also we can access and store the data that we can get from the user and store it in a union. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to create a union to store bank account data. If it can either store an account number as an integer or account type as a character, and we would like to display data based on user input. We are having a union called bank account. It has two variables, one integer, one character, called respectively account number and account type. This is my union. I create an object of this union bank account. So I type down the bank account because I want to create an object of this union, and then I type down the name of my object, which is account here. I'm having a variable called choice of integer type. I show this message to the user. Enter the type of data to store. Then if the user wants to, for example, enter an account number, I would tell them to enter 1. If they want to enter the account type, I would like to ask them to enter 2 here for us. Then whatever the user is going to enter, 1 or 2, is going to be stored in the choice variable here. Then using the if conditions, we can proceed with the program. We are checking this condition if the asked number from the user that is stored in choice variable equals to 1. We further ask the user to enter account number, and then we store it in our union. How? I use the object of my union, so account number, which is the variable for integers that we would like to use, and then show this message to the user. Okay, account number, colon, and then print the entered and stored number in this variable. And if the user enters 2 here, for example, they would like to store account type, this part is not going to be executed because choice equals 2. So this statement is not true. Therefore, this part of the condition is not going to be implemented. And it goes to check this part. So 2 equals 2. Yes, this statement is true. This condition is true. Therefore, this part of the code is going to be executed. Okay, we are going to ask the user enter account type. For example, S for saving, C for current. Then we are going to store whatever the user is entering in the account type variable of my bank account union using the account object. Okay, and then after storing it, we are showing this message account type, and then again here I'm showing whatever that is stored in this variable in the output. And if neither 1 nor 2 is entered by the user, we are showing this message invalid choice. So when I run this code, it says enter the data to store. Here is the message. 1 account number, 2 account type. So I type down 1 and it says enter account number. So when I type down 1, choice equals 1, and when choice equals 1, this condition is true. Therefore, it is going to enter this part and it shows me the message enter account number, which is here. Then whatever that I enter is going to be stored in the account number variable in my union here, okay, using the account object. So I would say, for example, 12, 13, 14 is my account number. I assume that. Then it is going to show this message to me in the output account number, and then prints whatever that is stored in that variable. And if I, for example, type down 2, it says that, for example, enter account type, I would say S. It says account type S means for saving here. And if I run the program one more time and I enter, for example, number 4, while it was asking me to enter 1 or 2. So it says invalid choice in the output because 4 is neither of the cases here. So this is how we can have a union for bank account to store data using a union in for bank accounts data, and we ask the user to enter information, and based on what the user is going to enter, we're going to store in different variables of our union. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that uses a union to demonstrate how multiple variables can share the same memory space. Here is my union called data. It has 3 variables. Int value is of integer type, float value is of float type, and char value is of character type in my union data. So there are 3 variables here. I create an object of this union data, and the object name is data as well with a small letter D. Then we would like to initialize an integer value. I type down data, the object dot the name of my integer variable that is called int value and equals to 42. After that, I print this value in the terminal, so using the object and then the name of the variable. I also have a float being there, so I type down the name of the variable that is for float, so float value, and before that I use the object data dot float value equals to 3.14, and we are showing this in the output. The same logic goes for the character. We are having a character A being stored in the char value variable using the object data, and then I'm showing this message in the output and showing it like this. For example, character value colon and then show the stored character in the char value variable from the union data. However, what is very important here is that we would like to show that, for example, when we are having this character being stored in our union, it is going to overwrite the float, and when the float is being written there, it is going to overwrite the integer. This is one of the features of the unions, if you remember. So in the firstly, I'm having the integer, then I'm overwriting it with a float, then I'm overwriting it with a character, and finally, to show that it overwrites, we are saying that okay, finally we have a character being stored because they are sharing the memory. I am printing out the int value, so the first variable, one more time, so you would see that it takes a garbage value in the output because they share the memory space, and the character is going to be overwriting all the previous variables that were initialized. So when I run this code, I see that okay, integer value equals 42 and integer value 42 is being printed. Then float value equals 3.14. It is being printed in the output. Then we are having a character here. For example, character value A is being printed out. But when we are having this integer, after that we are having the float. So when the float is being initialized, it is overwriting the integer. So there is no integer anymore. And when we are having the character being initialized, we are overwriting it, overwriting the float, in fact. So there is no float anymore. This is why when we are having the last element being initialized, in this case is the A character, and after that I try to access this 42 that is an integer value and it is stored in int value. When I would like to print it in the output, I would say after assigning char, int value, integer value is taking, you see, this is the number. So this is a garbage value in the output, you see, and the reason is because the character is going to override that. This is why. So for example, if I comment these 2 lines and also these 2 lines and I run, because I'm having only an integer being initialized and then I'm having the integer in the output. Again, here there should be no problem. You see 42 and 42 is being printed in the output. But if I have this, for example, float data type being initialized, it is going to override the integer. So this part we expect to see a garbage now. So when I run this code one more time, you see that in the first run, in the first part, we are having the integer value 42 is being printed. The float is being printed now. But when I'm having the integer again after printing the float, after initializing the float, we see that it takes a garbage value because float overwrites the integer. So this is what we need, why we need to be careful while using unions. They are very good for memory efficiency, but we need to be careful about it. Whenever we are initializing a new variable, it is going to override the previously initialized variable. Thank you for watching.